Okay, today's objective is that we're going to program a linked list where we will be able to insert items or nodes in the front and in the back. We're going to do this with a class. Okay, so the last time we did this was with a structure, and we also had a loop that allowed us to enter several nodes and had the list grow accordingly. So, but this time we will have the program control the way we insert the items into the list. We're going to have two options. One, we're going to enter it from the front, and the other one will be from the back. Okay, so I've created a directory here under lists. So this will be list version 1. So this will be our first experiment on how to build one using classes and an application. So we will have a header file, one will be a .h file plus its implementation, and a test application file. The reason I have the virtual machine here on my Mac is so I make it easy for some people who have Windows. My previous programs were used, that I demonstrated used directly platforms that were compatible to Mac. So now I'm going to use something that is compatible to Windows. Okay. All right. So I am going to store my project right here. I always like to have everything cleared out as to where things are going to be stored, especially if I have linking issues, which could easily happen if things are not stored properly. So I'm going to minimize this for now. Let's see here. This is my virtual machine here. I'm going to go to devc++. By the way, this is free to download. If you go on Google and you type devc++, you will get this application. You can download it. Now, the one I have here on this virtual machine is quite old. I believe there are newer versions than the one that I have here. Okay, so the first thing you want to do is start a project, unlike the previous example for the linked list where we did a single file. So this time I'm going to go ahead and say project. It's going to be a console project. I'm going to name it, and for this project I'm going to call it project list version 1, just in case I create another version. This will be a C++ project, so I'm going to hit OK there. It's going to ask me where to save it, so obviously I want it under code testing. This would be under lists and list version 1, the directory you created before. Now be careful, this is a .dev extension. This is not the .cpp application yet. Okay, so I'm going to hit save, and I automatically get this main function here where I can get started. Now if I hit save here, now this file hasn't been saved yet, so it's going to ask me what do you want to do. I'm going to call this one list app version 1 within the same project. Now this one is a .cpp file, so there. Okay, so you can run most programs here. I've got the standard library cstdlib. Now that's going to be nice because I'm going to be using the null pointer, so that's included there. IOStream is going to be interesting because I can use CNC out for this example. Here's what I'd like to do. I'd like to have a menu-driven program. So let me write up kind of what I want the application to do, and then we'll worry about, okay, what will be the user-defined class that I will design for this, for the implementation. So I would like to have something maybe, let me write down the prototype, and make this program as streamlined as possible. So I want an int menu right here. And the idea behind this is I'll have a selection of possibilities in terms of what do I want to do with a list. So maybe something like this in choice. And then we'll have cout. This could be main menu /n. I'll keep everything as a stream here. And one insert. I'm thinking about the payload we're going to be doing. Maybe an integer for now. So as we develop this program further, we could see what other payloads we could use. All right, so especially when we use templates in the future. So for now, simple integers. Insert an integer front of the list. Okay, so that would be a choice. If you pick one, that's what will happen. Next, it'll be to insert an integer at the back of the list, /n. Now, it would be nice also to be able to see or visualize what we inserted here. So maybe something like this. 3, it will be view the list or list content. /n. That's going to tell me, as I test the program, if my insertion is done correctly or not. Next will be for exit. So this will allow me to get out of the application itself. Okay. And I will have, the last line will be the choice. So something like this, enter your choice. Okay. Put a semicolon here. Keep the prompt right there. So cn choice and simply return choice. Okay, so that's this phase right here. We can go ahead and write some sort of a frame here for this to work. Oops, not here. I'm going to go over here. And probably something like this, int option. And we're going to do a do while loop. Let me realign this here. Do a while loop based on option is not equal to 4, since 4 is our signal to exit. Now, obviously, inside the loop, you need to call menu and assign the return value to option. So option equal menu. So you have a function call to menu. Okay. Quick test right now. You could actually test this. So let's compile and run. There you go. Let me make this a little bigger here as far as the output property. There you go. All right, so if we enter 1, we stay here. 2, we enter here. 3, we enter here. 4 kicks us out. Perfect. That's where we want to be. And we would like to have our options here. So you could do a nested if statements for this, or a series of if statements. A switch statement is an appropriate one to go over here, and it will be based on the value of option. Okay. And let me just make sure I close my brace here so I don't forget that I started one, obviously. So case, if you choose one, and I'm just going to do a break for now. I'm going to leave these case 2, and then we'll put a break here. Case 3. We'll put a break here. Case 4, might as well print goodbye. So cout, goodbye. And then a /n, semicolon. You still need to do a break here. No need to do a break after you do default. And default means you picked anything other than 1, 2, 3, 4. So you might as well print an error message here. Invalid choice, since that was the word you used in the menu anyway. Yes, stay consistent with your wordings. Okay, so here you go. Let's see how this works. So compile and run. Okay, so I'm going to pick 7. We know it's not in there. Invalid choice. Okay, if you pick 2, nothing will happen. You pick 4, you're going to get goodbye. Press any key to continue. So we've got something in here going. So what we'd like to do is a couple things. We would like to, right here, include a user-defined header file for, or a header file for a user-defined class. A header file for a user-defined class. Okay. Now, this class will handle the linked list that we want. So we could create nodes from within that class. We could insert nodes either in the front or the back, and we could view all the nodes as a list. So it's going to be an all-in-one. So what you might want to do here is you might want to declare a pointer based on that class, the included class, and set it to null. And the reason is you want to make sure that you're starting with an empty list, which means you're pointing to null to begin with. All right, so we're going to leave that. So everything you're seeing here is I'm writing up the strategy how I want my application to run. Typically, I'd go the other way around. I write the classes, whatever they do, and then I write the application around it. This time I want to go this way. I want to kind of specify how things will work and what I would want the class to do. Okay? So for example, here what's going to happen is you're going to insert, you're going to use, so let me just write down, use a method from within the class to insert data in the front. So first, maybe you might want to ask the user to enter some data, right? So you could have something like this, int data, right? And what's going to happen is we're going to use a function later on to do this. So first, you may want to ask the user, so say cout, enter an integer to store at the front of the list. And then you will do cin data. So what's going to happen is we're going to have a function somewhere, and but for that to happen, I wrote my declaration in the wrong place. So let me move this one right here. It's going to do this in main. So let me cut that, put it here in main. You're going to do it right here. Right here. That's where you're going to declare it, obviously, so you have access to it. So that function obviously has been defined within that class. Okay, so you're going to do a function call, okay? And you're going to pass along, okay, so pass the pointer and the data to that function. So roughly, this is what I want. So my design may or may not be exactly this, but that is my strategy. That's what I want to do. So that way the data is inserted in that list. We're going to do the same thing for case 2. So very similar idea. So let me just copy this and paste it here. And let me just move this here. Tab it here a little bit. There you go. And this one to store at the back of the list. And this one be method to insert data at the back of the list. And this one, insert data at the front of the list. Okay. You're going to pass a pointer and the data to that function. Okay. This one here, you will simply call a function defined again, or a method. Let's call it method. Again, defined within the class, to print the content of the list. Okay, then again, my strategy is laid out here. That's what I want to do. That's what I want to do here. So that gives me ideas as to how I want to structure my class as we move forward. Okay, well, let's get started on that. So right now, let me just compile all this to make sure I didn't make any boo-boos. I don't need to run, just compile it for now, just to make sure I didn't mess up anything. Very good. All right, so we're going to start with a new file now within the same project. And is this going to be my class file? So I'm going to say yes. This would be, and I'm going to call it list, the actual file, I'm going to call it list. So this would be a list.h. Okay. So what's going to have in it? It's going to be a class list, and that's what I'm going to call it. Open curly brace. Make sure you close your curly brace and put a semicolon. And I'm going to have my public interfaces right here. My constructors, my mutators, my accessors all will be here. And then here, I'm going to have the attributes that I'm going to need for this. Obviously, I need a payload. This is still a list. And notice that for now, my data will be an integer, so my payload will be an integer. So int payload. So I'm going to call it payload. Next, I need a pointer of type list, same as class. So this is very similar to when we did node, and we did a struct node, and we did a node asterisk next. This is very similar in concept. So list asterisk. And we're going to call this one pointer next. Okay, so let me save this right now as my .h file. So this would be a .h file. Make sure your extension is .h already. Make sure you spell this correctly the way you want. And I'm going to call it list, capital L. Good idea to save your class names with a capital in the front. Okay, and save. There you have it. So list is right here. And I have this. By the way, you can include now list.h in your program. All right, so let's do it here. Oops, right there. And we could do that. Include list.h. Okay, now is probably a good time to go ahead and link them. So let's go ahead and do execute, rebuild all, and there you go. Okay, so everything is good. Actually, you could, for now, set up, you could do something like this, list, asterisk, and call it my list. All right, so here you have a pointer of type list. Now, you would say, could you create simply an object of type list? Yeah, you could, except if I do that, depending on how I set up the constructors, I might have a node already in it. And the reason is I want a pointer and initialize to null. I want to have control over the generation of nodes within the methods of within the insertion methods, either in the front or the back. Okay, so I don't want the constructor to necessarily create a node for me, and then I have an extra node that I'm chasing within my list. So it's just a technique that you will see in a minute will work a lot better than if you did list without the asterisk my list, which basically you create an actual full object. All right, so I just need a pointer. So let's see if it actually accepts it. If I hit compile, it's perfect. So code-wise, syntax-wise, we're good. Okay, so what's going to happen is we're going to need some accessor methods, right? Actually, mutator methods, since we're going to change the attribute value with this data right here, the payload. That would be a mutator method for this one. This also will be a mutator method. Number 3 will be an accessor method. Okay, so let's prototype these methods right here. What are the things I'm going to need? I'm going to use some words because eventually later on I'm going to reuse them again. So if I want, for example, to put data in the front, I could have said insert front. I'm going to use the word push front. Now, I'm being strategic here. I'm shooting for the next project where we're going to get into stacks and queues. So we're going to use the word push and pop eventually. But at this stage, I'm just going to call it pushFront as a function. It doesn't have to return anything. So basically, I'm going to do something like this. pushFront. So this will be a mutator. And what would it do? Well, it's going to have to take a list, pointer, reference, comma, and I'm going to have it also take in the actual data that you want to supply. By the way, I don't need to formalize this for now, so I'm just going to do this. That's what I want, pushFront. All right, so this is an informal prototype here. You could do this in the classes. Obviously, if I link everything right now, everything is fine. Okay, I'm going to do the same thing for pushback. So void pushback. This will insert at the end of the list. Okay, same strategy. List asterisk and %. Notice this is informal. Int will be the payload that I would want. Next, I have to think of the constructors. I could have a default constructor. I could have an overloaded constructor. I could have both. I am thinking of having both. But I really probably will simply need an overloaded constructor where I can actually, at the moment of creating an object of any of list, I can insert the data right away. And I can do that within the function definitions for the implementation for this header file. So we'll see. So at this stage, these are the ones that I'm looking at. Well, just go ahead and put the prototype for the constructors. And I'm going to have list. So this will be my default constructor. And this would be my list. And it will take an int, just so we know. This will set up, if you use it, it will take the payload right away. Now for these two, what I'm going to do is, since it's a node inside that will be created, if you create an object of type list, I will make next, the pointer next, point to null. Okay, all right, or equal null. All right, so what else? I need to print. So void. So again, these will be my constructors here. So let me just write down formally what I'm doing here. These are my constructors. These here are going to be my mutators. And finally here, I'm going to do my accessor. I'll only need one for now. And this one will have a void. I'm going to have it actually print everything for me. And I would say ViewList, print list, whatever you want to call it. ViewList. And I'm going to make it a const function since I don't want anything to change. I'm just going to pass along an actual pointer. And I'm going to make this const. So that way, I don't make any mistakes in changing values or for the attributes within this function. So that's my initial idea as to how I'm going to do this. Again, I might change some of this as I move forward. Okay, so let me save this just to make sure everything's good. Now, if I try to rebuild this, I may run into some issues, but it looks like it's okay for now. Okay, my computer seems to want to update, so let me just postpone it before it does something on us. There you go. Okay. It's a good thing I caught it right now. Okay, so I need to define these functions. And I obviously need to use them right here. And what's going to happen, if I want to use it, you could tell exactly how I'm going to use this. The push front will be for number 1. And let's go ahead and set it up. All right, let's go ahead and set it up. Oh, by the way, I want my list to be equal to null. So I mentioned that earlier. I want that pointer to be null. So that means the list is empty. That's going to be a good indicator to show that's the beginning. So the first time I pass it, you're really passing that null value. And how are you going to do that? Well, you're going to need something like this. MyList. Now remember, MyList is not an object, it's a pointer. So you're going to have to dereference in this manner. Okay, and what is the function name? In my case, it's called pushFront. And you're going to pass MyList and the data you have here. So my data, the data itself will be by value. So that's how you're going to do it. So as you can see in the application, I'm trying to keep my code as simple as possible. That is my strategy for how I'm going to push data to the front of the list. And again, if this doesn't work, I can always modify it, figure out what needs to be done. So, from my experience, this will work. So again, how about for the other one? MyList. And again, it's a pointer. So make sure you're dereferencing pushBack. Okay. And you're going to pass MyList and the data by value as well. And for the printing, right here, again, MyList and dereference. What was the name of the function that I did here? ViewList. Or you could say ViewList. And that would be MyList. So that is the strategy that I have in mind on how to access the attributes through these two accessors and change their values and set them accordingly onto the list. And this one here will allow me to see all of them. Now, I haven't defined these functions, so now I'm probably going to get an error message if I try to rebuild all this. And sure enough, as you can see, I haven't defined these functions as to what they do. Okay, so we need another file. We need another file, and that file will be the implementation file for this header file. Okay, so how's that going to work? So you need a new file. You're going to say yes, and this would be list.cpp. And make sure that you include and list. Now, this is a user-defined header, so between quotes, list.h. Okay. Another thing I might want to include here, since I'm going to use the null indicator here or pointer, is this right here and IOStream. I'm going to need these two because I'm going to do a C out somewhere and using namespace as well. So I'm going to copy these, go back here, do it above it right here, and then using namespace. You could do it afterward. There you go. Stream. And then using namespace. I see. All right. So now let me save all of this. This here will be a .cpp file. Name it list. And there you go. Now, what I like to do is break it down into constructors, mutators, and accessors. Okay, so typically that's what I do here. So under constructors, I'm going to simply define what the default constructor do and the overloaded constructor will do. Right, so I have two constructors, remember? I have a default constructor list, and I have an overloaded constructor that takes an integer. So for now, let me move this right next to it so that way I don't make any boo-boos here. And the way you define these is within the scope of, as you can see this, so the compiler picks it up. I'm just going to pick the second one here, which is the default constructor. I'm just going to put curly braces now, nothing in there. I'm going to do the same thing, and I'm going to define what's in them. I'm going to do the same thing here. I'm going to do a list. This is for the overloaded constructor, by the way. And again, this would be this one. And I'm going to have an int value, for example. Let's say you insert a value, or whatever you want to say, data, whatever you want. And I'm going to put a curly brace for now. I don't like to write any code for them yet until I see what I can do with my mutators. Maybe I need a special function that specializes in entering data into the... okay, so maybe I can go to list here. Maybe I have a special function here that says void. This could be a utility function, basically. InsertData. Just in case I create something with a default constructor, and now I want to insert data in that object, if you create an object of it. So maybe int here. Okay. So I'm going to use the InsertData function, and I could set the rules there as to how to insert data. Say your program says you can only insert grades from 0 to 100. That means you could set the rules in the InsertData function. Okay. So I'm going to go over here, and I'm going to do my void, and that would be list, and that would be my insert data, and you can set the rules for it. So int your data, whatever you want to enter, and I'm going to call it, I'm going to simply for now set the payload to that without any conditions. So you could say payload equals data. So this is really where the value is set up. Okay, so now I could use the insert data in my constructors. Obviously, if my program was custom, where again, I need a range, only is allowed. And so you could do your data validation right here. This is why this is nice to set up right here. Okay, if you don't need anything like that, you could have done it here and here and you're done. Payload equal data or payload equals 0. Here, I could set it to 0. You could initialize a whole bunch of things here while you're in the constructor. So you could do something like this. Insert data and then set it to 0 if you want. That will be an initial. So if you create a node using the list class, then the data automatically will be 0 right now. And while you're at it, set the pointer to null. And how are you going to do that? Well, it will be this class, whatever you're using, and then next, null. So probably something like this. This, next, equal null. Something like this. Okay? You could do the same thing here, except this time, insert data. Except now you're going to pass value to it that you had as a parameter for that overloaded constructor. And this will still be the same. You need to set it to null right here. Oops, forgot to say next equal null. Okay, that's what happens when you write code from scratch. Okay, so bear with me as we move forward. Let me rebuild all here. Now, obviously, as I do that, you're going to get some errors on the functions that I still haven't defined. Okay, so I'm going to go over here, still work on my mutators now, even if they don't do anything. So I'm pretty happy with the constructors right now. They fulfill my requirements. One sets, so they're handling the attributes that I have here, the payload and the pointer next of type list. Okay, so now let's go over to void list. So we're going to go over to each one of them. Luckily, the compiler here shows me what you want. Push front, and that would be list, asterisk, and percent. Typically, what you want at this stage is to pass the head of the structure. Okay, so if it's a list, obviously it's a data structure, and I'm going to pass the head. I'm going to call it the head, and that's exactly what the idea is. And then int data. Right? You can call it value, whatever you want. Okay. And I'm not going to do any implementation right now because I want to just compile everything and make sure everything links up nicely. Okay. Notice here I haven't defined the function really, but it exists. It's defined to do nothing. Okay. So we'll get back to it. And then list pushback. That would be this one right here. And again, list, asterisk, and head. So same idea. Int data. We're going to open and close the curly braces, even though it doesn't do anything. So right now, okay. Okay, let me hit save here. Sometimes this compiler tends to freeze. Then I lose whatever I type. So I just want to make sure that. All right, so my accessor, what else I'm left with? My ViewList. Okay. ViewList, again, it has a void return type, list. And that would be the ViewList right here. And that would be list asterisk. And again, this time simply head. Okay. And then const. Okay. Do not forget the word const. It simply means this enforces a rule, basically. You cannot make changes to the attributes. Okay. You could do whatever you want inside of it. Simply will not be able to change the attributes that you define here within this class, these private data members. Okay, which is a good thing because you just want to print the content. In your case, you just want to print the payload, and hopefully everything gets printed out in the order that you entered it, front or back. Okay. All right. So now is a good idea. Go ahead and rebuild all. Good. New news is good news. So we're doing really well here. Okay. So on the application side, believe it or not, we're done. It's done. So now it's just a matter of making sure that the work is done right here. This application is a testing program that allows us to verify and design these these push front and push back in ViewList and how they work. So this is going to take us back to the basics of how a list is accessed, how do we look at it, and so on and so forth. Now, from a view list, this is going to be similar to the previous video we did in terms of displaying the content of a list. So it doesn't matter if you inserted data in the front and the back. It's a matter of the moment you capture that list as a head, you need to step through it. And you have a head already, so maybe use a temporary pointer and make that temporary pointer print whatever it's pointing at, and then move that temporary pointer across the whole data structure. So that's the strategy for this one. I will start with this one because we're going to use this view list to verify if our push front and push back works as I start developing these. So I'm going to start right here. This way I'll have the ability to verify if my results are being stored. Okay? So, probably a good idea here to do list, asterisk, and I'm going to call this one position. Now I've used that word before just to make sure we understand that this is a temporary pointer, and I'm going to make it equal to head right away. So don't waste any time. Make it point to the beginning of the list. Okay? Now, your list may or may not be empty. If it is empty, head will be null. How do you know that? Let's go back to the application. Remember, head is just a pointer. You're going to pass my list over to view list. Now, if it's the first time you've done it, you're going to pass this null here. So indeed, the loop will stop there, and you're not going to print anything. So so we're going to do a loop here, and you're going to say something like this. So if the position next is null, it's not going to print anything. There's nothing. So in that case, position equals null. All right? So you're not going to print anything if the head is empty, right? If it's pointing to null, right? Your data structure. If not, well, you're going to do quite a couple things here. Well, first, you're going to have to print. Now, for me to do a cout here, I'm going to make sure that I have IOStream, namespace is good. So again, here is a good idea to go ahead and print the content of the payload. So go ahead and do a cout. And you could say something like this, payload equals, and then maybe something, oops, the other way. Sorry about that. And then we're going to do, this would be position, dereference the payload right here. Okay, so you're using the pointer. Now remember, at that moment, you have actual objects that you're going through. The pointer is just pointing at them. So if it's your first element and it wasn't pointing to null, so that means position next is not null. We're good. We get to see the payload here. But you need to do one more thing. Now you need to move the position. Since your while loop is based on the condition that position, okay, I'm sorry, is not equal to null. Notice my not equal to null. Okay, so as long as it's not equal to null, you're going to do this. If it's equal to null, there's no point of doing anything. Okay, so what we're going to do now is move position. So position will be equal to position next. Right, so this is how you move the pointer. Right, so this is how you move, move the pointer. Otherwise, you're going to be stuck on the first element. Okay, so that's pretty much it here. You're not doing anything else other than seeing what's going on here. So let's see, rebuild all. Everything looks good. Actually, we can run this. We can go to the application right here. And if we do compile and run, we're not going to see anything. So compile and run. And if you do 3, obviously there's nothing here. If you do 1, you haven't done anything here. You enter a 2, you do a 3. You could see by doing 3, I wanted to make sure that I don't run into a memory issue. If there was anything in terms of memory access, my computer here will freeze or something will happen. That didn't do it, but that's not always true. So everything is good right now. Okay, so that is the strategy that I have for printing the content of the list. Good. So now let's think about how we're going to insert data to the front of the list. To do this, there are 2 situations. One, either you just started and you have no data, which means the pointer mylist is actually equal to null. Or you actually have data. So that means you've looped through this, you've used push front several times or a push back sometime, which means now you have data, so your first element is not null. So there is going to be an if statement here. However, your list may or may have more than one item. So I'm going to have a loop to step through my whole list to go to the end of it, to be able to insert the new node, notice the word I'm using, the new node that I will create. Aha. Okay, so let's go back to that function. So this is where we're going to dynamically allocate space for new nodes. Okay, so push front and push back is when we're going to create new nodes. Okay, so first, I need some sort of a temporary pointer that I'm going to use, just like I did for ViewList, to be able to move through the list to the end of it to add, which basically is the front, and add items there. Well, first I'm going to set it up to the front. So I'm going to do list. And this pointer, I'm going to call it last, since it will eventually go to the end. That's where I want it to be. So list asterisk, and I'm going to call it last, and I'm going to make it equal to head. So this is important right here, right now. I have a pointer last equal to the pointer head, which is perfect. So if there is no data, last is null as well. If not, it's not. Now is a good time to go ahead and create a new node. So the fact that you're here is you're trying to create a new node. Aha. Okay, so if you're trying to create a new node, you're trying to supply it with this data. Well, that's a good time to use the overloaded constructor that we have here, and to do it dynamically. So we're going to do it right here. We're going to do list, asterisk, my node. So this is the new node, equals new. Now, if you're going to use the keyword new, obviously this has to be a pointer. Okay. And then list, and use the overloaded constructor and set your data to it. There. That automatically, what it will do, it will insert the value that you just did and set next to null. That's fine, because this new node is not linked yet, but you want it to point to null, so because it's going to go to the end of the list, right, in the front, and you don't want to modify its next attribute, so you want to keep it there. You only need to assign the last member of the list to my node. We're going to do that after we do a loop. Why? Because we want to move the pointer last to the end of the data structure. But to do that, you need, like I said before, you need an if statement to make sure, are you at the beginning of it, and if of the list? If you are, simply set head to my new node, and you're done. So if head equals null, right? That means you are at the beginning. That means that was the first time ever you've tried to create a new node, right? Which means the pointer in the application was null. And this is the first time you did case one. Well, that's great. You're passing null across. That means go ahead and create your new node that you created, assign it to head. So head equal my node. That satisfies that requirement. Okay. Else, which means you just came back from another trip where prior to that, you've inserted data, you have data, so the head is not null. Well, that's great, but now you need to go to the end of it. So you need to move that pointer last that I have there, or what we call a temporary pointer. You're going to leave head alone, right? So, but you're going to move the last pointer to the end. You need a while loop for that. And simply, you're going to use this. While last next is not equal to null. Right? So that would be the condition that I would use, and move that pointer last, make it equal to the next element. Last, oops, arrow next. Right? So this is how you move the pointer. Okay, so that while loop allowed me to move the pointer. That's all you need. You're at the end now. Now is the time to insert the new node. Well, last next now should point to the new node. That's it. That's the algorithm to do this. Well, let's test it out. Let's see if it works. So let me save this. So now we can test one at a time. I'm going to go over here to, it's going to run case one. Case two isn't doing anything yet. So let me go ahead and compile and run here. Excuse me. So if I do 1, I'm going to enter 22. Let's do 3. View if the data is in there. Sure enough, 22 is in there. Let me enter 1 again to choose to insert in the front of the list. I'm going to enter a -33. Let me do a 3 again to see what if we're seeing it. And sure enough, so it's pushing it to the front. Okay, so let's do it again. And I'm going to enter this time 78. And I'm do a 3. So that should be the last element in there. It's pushing it to the front of the list. So 20 in the order in which we're entering these things. It's perfect. So now we see that it works. I would like to do option number 2. I'd like to see how option number 2 can be handled. All right, so let me exit this. So 4 to exit. Okay. All right. So let's go over here. The ideas are going to be very similar. I don't think I'm going to need a loop here. Because, yeah, I'm not. because every time you're going to pass the head. So you really want to go behind it. So you really want to go behind the head. So it means head will be the new, you're going to assign it to the new node. So head will be equal to my new node somehow. Okay, but then again, you still have two possibilities. Head could be null. In that case, that will be my node. Else, you're going to have to do something else, right? So let's see what I need here. So no matter what, you're going to need a new node, right? Dynamically allocated. So if you're doing push front, push back, you're going to need a new node. So that's fundamental for these two operations or these two methods. You're going to need list asterisk my node equals new, and I'm replicating what I'm seeing above here. And hey, use the overall overloaded constructor. It works perfect for that purpose. And now I'm going to do my if statement. Fairly straightforward. I'm going to check if the head is null. If not, do something else, right? So if, and again, head equals null. Then make head equal this new, my node. That's because it was empty. You had nothing to begin with, right? That means you started the program and you went straight to option 2 while the program is running and ran pushback. Well, if you did that, you passed this null over to that function with whatever data you had. Else means you either inserted data using pushback or push front, right? I'm going to probably need a couple statements. I'm going to put curly braces just in case. Let me see here. And the first thing I'm going to do is, before you do anything, make sure that my node next is pointing to head. You are linking the list, right? I forgot to mention here, you're link the object or link the node to the list. That's what we want to do. We want to link, same thing here. I'm going to do my node, right? So this time it's this way, my node next. Now remember, my node next is null when you first created. When you did this, you use this constructor here. And my node next is null, but now I want it to point to head. I want it to be equal to head. That's not enough. Now I'm going to have to move head. Remember, I passed it by reference. So I can change the value of head now. Head equals my node. So that's it. I think that's all you're going to need for this algorithm to work. Okay, let's test it out. And the reason is, again, so here you're pointing the new node to the head of the list. And now what you're doing is make the new node the head of the list. That's what you did here. That's the logic behind this code. Now let's see if it works. So I'm going to save this. We're going to go back here. We're going to compile and run here and see how it works. So let's start with number 2. First of all, if I do 3, obviously I have nothing. Let's do 2. And let's put an 8. Let's do 2 again. Or let's do a 3. Let's see if it inserted. Okay, 8 got inserted. There's no garbage, which is good. My program didn't hang, which happens a lot when you're dealing with dynamic memory allocation and pointers. You could easily crash your program. So I'm doing good. So I'm going to go ahead and insert again at 2. And I'm going to do -7. Let's see what happens. And if I do 3, perfect. -7 now is above 8. Now what if I did 1? Right? So if I do 1, I want to insert to the front. And I want to do an 11. So 11 should come out after 8. So let's go ahead and see. And sure enough, it did. So I can do both now. Insert front, insert back. So let's do a couple insert back. Let's put a 0. Let's do again a 2. And 39. Excellent. Let's do a front. And I will do 40. Now let's go ahead and see the whole thing. And here they are. Okay? Excellent. So my next objective is to improve on this program. And one way to do this is we're going to use probably another form of data structures other than lists. And what I would like to do eventually is take list and make it a parent class to 2 subclasses, which will be a good review for inheritance, and reuse push front and push back more specifically with the children class, where we're going to have also some pop function. That will lead us to stacks and queues. Okay? So we could have a stack and a queue children of a list, but with specialized functions and specialized methods of data access. So this is a start. Okay? And I'm not sure how I'm going to upload this code over to YouTube. I should have a repository somewhere for this. But hopefully you followed me well enough to recreate this code, and I went slow enough for you to rewrite this code. I hope you enjoyed this. Thank you so much.